Now we take the another one combination of the semiconductor, and for this we come the new class of the electronics, that is digital electronics. There's the two type of the signal and two type of the circuits are there. The one signal is called analog signal and circuit. Analog circuit are the one in which the current and voltage varies continuously, and they can be represented by continuous change of the current or voltage like this, or it may be this way. In any of the way, if it is varying continuously, we say it is an analog signal. And any circuit which can respond to this analog signal, we call analog circuit. Now the another one class of the signal is a digital signal and digital circuit. Digital circuit. Digital signal are the one which can have only these discrete value, two fixed value, either 0 or 1 or +1 or -1. Like this. They are given by the pulse. They are given by these signal are represented by the pulse. They can have fixed value. So they can work only between the two values of the voltage and current. Such a signal we call digital signal. Their value, high and low value, are represented by the binary number. Binary number 0 and 1. 0 we represent low and 1 we represent high. Circuit which respond to these type of the digital signal is called the digital circuit. Now we come to the very special class of the digital circuits we call logic gate. These logic gate are the special digital circuit in which output and input both have got some logical relation. It follows some logical relation between the output voltage and the input voltage. These logic gate are represented by some graphic symbols. And we learn about what graphic symbols are there. They are made by the semiconductor, by the various combination of the PN junction or NPN junction, diode and transistor. Their input and output is represented by a mathematical table we call truth table. All possible combination of input and output can be mathematically represented by a table we call the truth table, in which we use the binary number 0 and 1 to represent the input and possible output, right? The basic one is NOT gate. NOT gate, the symbol of the graphic symbol of the log NOT gate is like this. It got one input, say X, and one output, say Y. This is the symbol of the NOT gate. What it do? It invert the input. Logic relation is Y is equal to X naught. We will say X naught. It invert the output. It's all possible input and output combination we can represent by the truth table. How we represent by truth table? We have got X input and Y output. If X is 0, output will be 1. If X is 1, output will be 0. This is the possible combination of the input and output. If X is low, output will be high. If X is high, output will be low. This is the truth table of it. It is not equivalent to, but it is like as you put the key and a bulb in parallel. When switch on the key, the bulb will not glow because all the current will bypass the bulb. But when we switch off the key, the bulb will glow. When key is switched off, bulb is glowing. When key is switched on, bulb is out. So this is just like working in logic gate. In form of the pulses, how we represent the output and input? Suppose here is a pulse X, input pulse. 0, 1, 0, 1. So what will be the output pulse? When there is a 0, there is a pulse. When there is when there is an input, there is no output. Again, when there is no input, there is an output and no input. So we get the output when there was no input. Next basic digital gate or logic gate is OR gate. The graphic symbol of the OR gate is like this. It has got the 2 input and 1 output. This is the logic symbol, graphic symbol of the OR gate. Now what it do? It add up the input. Output is a sum of the input. It is y is equal to a plus b. We call it a or b. It gives the output when either a or b or both of them at the higher value. For example, we can represent their output and input in the truth table format. So in the truth table, if we represent them, we get the we get the A input, we get the B input, the output is Y, output is A plus B. So we make a column for it. Input we represent all possible combination of the input. We can write 0, 1, 0, 1 and 0, 0, 1, 1. If you write this way, you got all possible combination of input and output. Now, Y is A plus B. 0 plus 0, 0. 1 plus 0, 1. 0 plus 1, 1. And 1 plus 1 is 1 only. In the binary, it is 1, 0. So what we obtain? When we say 0, 0, when both of them are at the low, we do get low, no output. When one is at high, either A or B or both of them is at high value, we get the output, right? It is just like when you connect the two switches in parallel, two key in parallel to the bulb. Switch A, switch B and bulb output Y. When either of the switch is on, the bulb will glow. If you switch on one, A, bulb is on. When switch on B, A is off, then bulb is on. When you switch on A or B, either of them, both of them, then also the bulb is on. So this is like this. How we can represent them in output in the pulse, in the form of the pulse. Here, suppose we represent the input A. This is A, 0, 1, 0, 1, 0, 1. It is B, 0, 0, 1, 1, 0, 0. It is B. Then what will be the output? Y. When 0, 0, there is no output. When 1, 0, it is 0, 0, 1, 1, 0, 0. 1, 0, there is an output. 0, 1, there is an output. 1, 1, there is an output pulse. And 0, 0, there is no output pulse. Again 1, 0, there is an output pulse. So we get the output here. We get the output when both of them or either of them are at 1. Our next gate is AND gate. It is another one basic gate. This gate gives the output, that is A and B are at high value. It has got 2 input and 1 output. Graphic symbol is just like in D, and 2 input A and B and 1 output. Y, you will get an output, that is Y, when both A and B are at high value. So we represent output logical relation is Y is equal to A into B. We call A and B. Their truth table can be given as Their truth table will be A, B and Y. A can be A and B, all possible combination. You can write by writing 0, 1, 0, 1, 0, 0, 1, 1. If you write in the two column in this way, then you got all possible combination of 0 and 1 for A and B. Now, what is Y? What is output? Output is A into B. 0 into 0, 0, 1 into 0, 0, 0 into 1, 0, 1 into 1, 1. So it gives output when A and B both are at 1. So that's why it is called the AND gate. It is just like when you connect two keys in series, A and B, to a bulb. This bulb will glow when both of them, A and B switches, are on. Then bulb will be on. Otherwise it will be off. Either of them if off, the bulb is off. It is similar way it works. In graphical form, how we can give the output and input? We represent input A 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, and this is B. Under the same place we put the graph 0, 0, 1, 1, 0, 0. Then what will be the output? It is 0, 0, 1, 1, 0, 0. What will be the output? Output will be where there is an 1 and 1. There is no output. 1, 0, there is no output. 0, 1, there is no output. There is an output only at this point. Then there is no output, there is no output. So we get output when both of the pulses are at 1, 1 high value. There we get the output. So that is the graphical representation of output of AND gate in form of the pulse. Universal gate are those circuits, by using them we can make all possible gate. We can make AND gate, we can make NOT gate, we can make OR gate, or any of the gate if we can make, then such a gate we call universal gate. They are the two universal gate. The first universal gate is NAND gate. NAND gate is short form of NOT plus AND. It is a NAND. This NAND gate basically made up of the one NOT gate following the AND gate. There is an AND gate, and if output of the AND gate is given to the NOT gate, then this makes the NAND gate. A, B and Y, this together makes the NAND gate. What is the logical symbol or graphic symbol of the NAND gate? The graphic symbol of the NAND gate is, it is an AND gate to input, and we put one circle over here at the end, and then there is an output Y. It is different from the NAND gate. You check by using a NOT over there. There is no NOT, here is a NOT. So that shows that it is a NAND gate. It is an and with the NOT. Relation is Y is equal to A and B NOT. NOT of the A and B is a and B NOT. How we can check it? What is an output? We can check it by using the truth table. If you use the truth table of it, truth table of the NAND gate will be A, B and Y. Y is A into B NOT. So it is 0, 1, 0, 1, 0, 0, 1, 1. The best way to write the column so that we got all possible input. Now the output is A into B NOT. 0 into 0, 0. NOT of it is 1. 1, 0, 1 into 0, 0. NOT of it is 1. 0 into 1, 0. NOT of it is 1. 1 into 1, 1. The invert of the 1 is 0. So that is an output. It is just invert to that of the input. This is the truth table of the NAND gate. right? Similarly, we have the another one universal gate, we got NOR gate. NOR gate is another one, second universal gate, by using which we can make any other basic gates too. What is NOR gate? NOR gate is basically short form of NOT plus OR. It is basically obtained by using the NOT gate in the output of OR gate. It is an OR gate. In the output we put the NOT gate. So here is an Y. This combination is now known as an NOR gate. The logical symbol of the NOR gate is OR gate, and we put a NOT at the end. A, B and Y. This is the NOR gate. This is the symbol of the NOR gate. It is an OR gate with a NOT. It is different from the OR gate. OR gate has no NOT. NOR gate has got NOR. Output relation Y will be A or B NOT. OR means plus. A plus B NOT. That will be the logical relation. The truth table will be, the truth table for the NOR gate will be, we write A, B, we write Y, Y is A plus B NOT. We write the combination 0, 1, 0, 1, 0, 0, 1, 1, and Y will be A plus B NOT. 0 plus 0, 0, the invert of it is 1. 1 plus 0, 1, invert of it is 0. 0 plus 1, 1, invert of it is 0. 1 plus 1 is 1, invert of it is 0. So we get output 0, 0, 1, 1, 0. It is the invert of the OR gate. After learning about these universal gate, now let us check how these universal gate can be utilized, can be used for making various other gates. Various other gates like AND gate, OR gate, NOT gate. So let's first take AND gate, NAND gate. NAND gate can be converted into NAND gate into NOT. How we can convert NAND gate into NOT? It's very simple. I show it by the graphical symbol. This is NAND gate. This is input of the NAND gate A and B. This is output of the NAND gate. What we did, we join the input and make it as a single input. We join A and B and make a single input. That is a X is the input and Y is output. It become NOT gate. Now how we can know that it become NOT? It become NOT if we can check it by the truth table. We make the truth table. We have X, we have A and B in the input and Y is an output. Y is A into B NOT. If we put input as in 0, X as in 0, then necessarily A and B will be 0. They cannot be no other combination except 0 because they are joined. So output will be 0 into 0, 0 and invert of it is 1. So at the 0 we get output 1. Similarly, if we put the input 1, then A and B will also be 1 and 1 only. There is no other choice. Then output will be 1 into 1, 1, invert of it is 0. So at the 0, 1, we get the output 1, 0. It has input. Reinvert the input. X has been inverted in the output. So it worked like a NOT gate. So now we have the, earlier we have the symbol of the NOT gate like this. You can also use in place of this gate too, this symbol too. Similarly, we have NOT from OR, not from NOR. How we can make the NOT gate from NOR gate? Again, same way, we have the NOR gate. These are the two input. We join the two input and make it one, X, A, B and the Y. This become NOT. How we can check it that if it's NOT or not? We got x, a, b and y. If x is 0, then a will be 0, b will be 0 and y is a plus b naught. So 0 plus 0 is 0 and invert of it is 1. So for 0 we get the 1. If we get x1, then a will be 1, b will be 1 and y will be 1 plus 1, 1 invert of it is 0, so we got the 0. So at 0, 1 we get the 1, 0. It is again working like a NOT gate. So we have the three possible NOT gate symbol. This, the original, this one made up from the NAND gate, this NOT gate is made up from the NOR gate. Now we get the another one combination. We want to get AND from the NAND. I told you the NAND is a universal gate. We want to get AND gate from the NAND. If you remember how we get the NAND, we get the NAND by connecting output of the AND gate to the NOT gate. Now this time to get the AND from the NAND, we connect the NAND gate to the input of a NOT gate. So the output will be now of the AND gate. NAND gate, this is the NAND gate connected to the NOT gate will give the AND gate. NAND plus NOT will give the AND. Sometime we don't use this symbol because we say that we have only the NAND gate with you. And from NAND only we have to make the AND. So even the NOT gate is to be used, the one which we obtained by using the NAND gate. So sometime rather than this NOT gate, we can also use the symbol NAND gate. And this is the NOT gate. This is NAND. This is NOT. This is the NOT made up of the NAND only. And this is the Y. This is A, B, and this is Y. How we can check key output is same as that of the AND gate? We can check it by the truth table. This output, let's mark it as an Y1. So if we make the truth table A, B, Y1 and Y, Y1 will be A into B naught. Y will be Y1 naught. So we make the truth table 0, 1, 0, 1, 0, 0, 1, 1. Y1 output will be A into B naught, 0 into 0, invert is 1. 1 into 0, 0, invert is 1. 0 into 1, 0, invert is 1. 1 into 1, 1, invert is 0. And invert of the Y1, it is 0, 0, 0, 1. This is NAND gate. This is the AND gate. This is the output of the AND gate. So logically we can write Y is equal to Y1 naught, and Y1 was A into B naught, and the whole naught will be again A into B. Similarly, we can make OR gate from the NOR gate. How we can make the OR gate from the NOR gate? Again, just like as you have done with the NAND gate, we connect the output of the NOR gate with the NOT. This is NOR plus NOT will be OR. Again, you are not advised generally to use this gate. You must use the NOT gate made up of the NOR only. So you can also make this symbol NOR gate. Output of this NOR gate is to be given to the NOT gate made up of the NOR only. A, B and Y is the one same thing. It is NOR, it is NOT, and output will be A plus B naught, and again naught of it will be A plus B. Again, by making the truth table, you can check if it is an OR or not. Now we want to make now OR gate from NAND gate. We have already convert a NOT gate from NAND gate. We already obtained NOT gate, AND gate from NAND gate. Now it is a time to get OR gate from NAND gate. Now how it is to be done? It is a little bit complex. Here first we give the input, say A, to the gate, this one. Can you tell me which gate it is? B is also given to the same. Which gate it is? Yes, it is a NOT gate. It is a NOT gate made from NAND. It is a NOT from NAND. It is a NOT gate. So input A and B both are first given to the NOT gate. Then output of this is given to the input of NAND gate. It is NAND. And this output will be the OR, the same as that of the OR. Now how to check? First we mark each output of the each gate as Y1 and Y2, and then finally the third gate is Y. What is Y1 here? A0. What is Y2 here? B0. What is Y here? Y1 into Y2 naught. That is A in A0, B0 separately, and not of the both of them. So it is A plus B. This is a Boolean algebra. Now how we can check it? We don't know about the Boolean algebra yet, but we can check it by making the truth table whether it is true or not. We can make the truth table. We can use A, B, Y1, Y2 and Y. Mark Y1 was what? A0, Y2 was B0 and Y was Y1 into Y2 naught. We make the column. We write the possible combination of A and B by writing in the sequence 0, 1, 0, 1 and B in the sequence 0, 0, 1, 1. Then we operate them as given in the column. Y1 will be A0, it will be 1, 0, 1, 0. Y2 will be B0, 1, 1, 0, 0. Y will be Y1 into Y2 naught. Y1 into Y2, 1 into 1, 1, and invert of it is 0. 0 into 1, 0. Invert of it is 1. 1 into 0, 0. Invert of it is 1. 0 into 0, 0. Invert of it is 1. This is the output of OR gate. So this way we got the NAND gate converted into OR gate, or we got OR gate from NAND gate. Similarly, you can get it AND gate from the NOR gate. Ditto same way we can get the AND from NOR.